Hey, it's a pleasure to be here. I don't know who let me talk, but thank you. I was here last year, so I actually don't want to know. But I have 30 minutes, not 20 minutes, which is fantastic, and I prepared for 20, which means I can kind of relax, and that's good. So yeah, my name is Craig Schallhammer, and I'm going to talk about AI, but we're going to really the focus is, it might not seem like it might seem like it's all about the app, but really the focus is on MySQL Enterprise Edition on-prem. And we're going to develop an AI and create an AI app that's like what's making it actually work. And it really works. And there's an associated hands-on lab that you guys can have access to. It's kind of like a private opening right now. I don't know when we'll actually make it public. So. All right, let's get going. So usually this is like the last slide, but I'm going to put it here at the beginning. Also, since you guys were MySQL friendly, I don't have to really try and convince you of something. But this is really what I want to hit home on. It's AI ready. I mean, it's got the vector, column type right there, and with that, just a little bit of coding wrapped around it, you can do some amazing AI stuff with it, and that's a big deal. One thing that I really learned by going through this is that you can create your app like on your laptop, and then you can deploy it anywhere. You can even deploy it like on a laptop, disconnect it from the internet, and it will still work. That's awesome. Okay, which means if you're a startup, you're like an indie developer or something like that, you can actually start with MySQL Enterprise Edition. And then if your app is a success, you don't have to think about migrating to another database or something like that. I mean, that's super attractive. The other thing that I forget this a lot is that, when you're dealing with just like the Oracle database or with MySQL, right? It's a database, and like we take for granted all the stuff that a databases naturally have, and so that's why I get a little irritated when people say, "Oh, the Oracle vector database." I'm like, that's like saying we have an integer database, we have a float type database. We don't have a vector database. It's just a type that we already use, and it's really the database. This is just one more thing. So you got a little passionate about that, right? Yeah. So, and it's actually super secure. And my point here is that if you architect this right, which is not a tricky thing to do, you can literally like run it on your laptop, flip off the Wi-Fi, and it still works. That's pretty secure. So that means your documents, your stuff, your content can be like sitting right next to you in your office. You disconnect it from the Ethernet, right? Boom, and it still works. That's pretty cool. So, all right, so real quick about myself. Yeah, my name is Craig. I work for Viscosity. I'm an Oracle ACE director. So most people don't know hear about what that is, but there's 23 ACE directors in the US. I didn't know this till a week ago, and 5 of them actually work for Viscosity. So that is super cool. It makes me feel like, wow, I've actually accomplished something in my life, So that's kind of fun. So I'm the founder of OraPub, which is all about Oracle training and its performance-related Oracle database, really centric, but now it's Postgres, now it's MySQL, got SQL Server, all that kind of stuff. And really that's like our training portal is the OraPub website. And Viscosity acquired OraPub about 3 or 4 years ago. It's just going great. So I started working with Oracle technology in '89. I was a young man at the time, and it's been a great ride. I worked for Oracle for actually 9 years. So, and this, I'm going to flip through me really quick, but this is actually relevant. In 1990, I wrote a tic-tac-toe program that learned and got better. And then I could play it after a while, and neither one of us would win. And how I did that, now it has a name, it's called reinforcement machine learning, but there was no word for that back then. That is so cool. I think that's pretty neat. So I'm really proud of that. A couple books, a couple classes, and I've actually deployed this stuff, just not talk about it all the time. What? No, I'm going to run out of time if we do that. Yeah. Okay. Raise your hand. I mean, if you want me to like pause or something like that. And, oh, you want to go back?
I like your books.
One more. There you go.
Wow.
All right. That's it.
You guys are like demanding.
Detail oriented.
Yeah. Okay. Yeah. Well, you're going to be able to download this thing like tonight, the whole slide deck too. Okay. Get that? Okay. Next slide. Okay, so one way, this is actually a RAG app. It's like all of Craig's stuff I've ever done that I put in this RAG app, as well as a bunch of viscosity stuff. And it is a RAG app, and it's called Shane AI because it's got like a surfer persona, the conversation you have. Shane AI, I know, it's that cool. I met like 3 other Shane guys this past month. I'm like, I guess it's not that special of a name anymore. Anyways, okay, we're burning time here. But it's an Oracle AI tuning assistant. Anybody can use it. You don't have to be like a member of OraPub or anything like that to do that. If you want to do it, if we'll give the URL and all that kind of stuff, just go to the viscosity like table. So, and Monica will be there. Monica, raise your hand. There's Monica. All right. And she will give you like the URL to the hands-on lab for all this as well too. So it looks really cool. So it's got a great little UI. We're actually redoing this right now. I have all the new content. It's being ingested. We're going to have like property graphs in there to help. It's going to be so cool, man. So, all right, viscosity. The viscosity is, we got a ton of services, education. We do a ton of migrations, which is a big deal now. On, off Oracle, Postgres to MySQL, stuff like that, right? On what? Well, it depends where. We'll take it from any side, kind of thing. Migration services, we do a ton of Exadata work as well. So it's just all different sizes and shapes, managed services. And it's just, fantastic people. There's me and I don't know if Charles, no, I think I'm the only one who's actually been here before. So yeah, great people, great books. Okay, let's get to the whole thing here.
That extra 10 minutes.
I know, I did. No, I didn't. 6. I was just counting. So the topics for today. So it might seem like it's all about the app, but the app is just a wrapper to somehow highlight all the underlying technology. And really the big thing here is AI-Powered. It's MySQL Enterprise Edition, and it's on-prem. That's a really big deal that I'm going to share with you. So what does it do? Well, you ask it any movie-related question. And you guys all know the Shaquilla database because you're MySQL people. I had no idea what that was until I'm like, what's going on? And I didn't know this. I didn't know they weren't real movies, right? Until I tried to chat GPT, like, what's this? And it's like, you're lying to me, Craig. Don't mess with me, kind of a thing. It was really weird. So anyways, if the movie is in the database, you'll get a fantastic response. And this is a simple RAG app that we're doing here. And if it's not there, you'll still get a pretty good answer. Like, hey, how about these movies or something like that. All right, so I'm going to go high level, low level here. So I'm going to start with this. Most people look at like a large language model, LLM, like just one big thing used to generate like another thing. Okay? But it's really convenient when we look at it kind of split. Whereas an LLM is going to have really good language capabilities, and it also has a lot of knowledge, a lot of context. What we want to do for a RAG app, I want to split that. I want to take the knowledge it has, and I just want to just throw it away. Actually, it's a distraction to me usually. What I want to do is bring in my context, my document, my knowledge, and leverage the LLM's language capabilities, put those together to get a really good natural language response. Okay, and that's really the essence of a RAG application. Okay, so here's how it works. There's a slide thing in the back there. If this is too small for you. Oh, first of all, what is RAG? Retrieval Augmented Generation. So you go to ChatGPT and you type in your request. That's like your prompt. Okay. Well, what we're going to do is that, like with ChatGPT, I can say, hey, here's my request, and here's like the document or the context that I want you to base the request on, or base the response on. Okay, so we're going to augment it. So where are we getting this augmented information? Well, of course we're going to get it from MySQL Enterprise Edition on-prem. Okay, we're getting it from the Shaquilla database. Database. So we got of course, that's not going to work. We have our user, we got a front end, which is just our HTML, CSS, real simple, really straightforward stuff. Then we got our back end, we're using Apache for that. This isn't PHP. PHP, I'm like, PHP, what is this? I didn't start using PHP until I started messing with MySQL. And like anybody can read PHP code. That's the beauty of it. Anybody, it's so straightforward. And then we're going to got some back and forth communication. We're going to use OpenAI. So for this app right here, we are actually going outside to OpenAI. And we're gonna use it for embeddings, and we're gonna use it for the LLM. I'm going to talk a lot about embeddings coming up here. That's where I'm going to burn most of my time. And then, of course, MySQL, we got our database and the vector type there. So that's kind of the main components of it. From a RAG request pipeline, okay, this is the actual RAG stuff in red right here. So we're going to get the request, what the user types in, what they're looking for. We're going to embed that. We're going to transform that into a series of numbers, okay, and we're going to talk a lot about that. Because we vectorized this or embedded it, that enables us to actually search the database because it has a vector type, and we're going to find related films that are related to our request. Okay, and then this is key. We have our prompt, which is initially just give me, this is what my request. We're going. Got freaked out there. All right, did you see me panic? Did you feel that right there? Yeah. So we got my request. We're going to add to that what we got back from our vector search, and we're going to give my request, the contents, the films, with some instructions, like answer my request based on this context only, and limit your response to 150 words or something like that. Okay, so there's 3 things that we're going to give it, and we're going to give that to the LLM, and boom, just like that, we get an answer, and usually it works really good. And so this is what the initial web app looks like. In the hands-on lab, there's kind of 2 parts. This is so cool. Only through prompting. We give you the prompts. You copy, you paste that into yep. Here we go. That's my sign. Is it doing something? Oh yeah, that's not the exciting one. But basically, you copy the prompt from the hands-on lab into Claude AI. It's going to give you the code, which then you actually create some files, right, in the compute instance. And this is what you're going to get out of it. Okay. Although this is accessing the database, the one where you copy and paste everything, it's just a normal kind of a chatbot. Okay. Anyways, so yeah, that's cool. Okay, so ingestion. The RAG usually has kind of 2 main broad areas. You ingest your documents, your content, and then you get it out. You make your request. Well, we're dealing with the database, so usually the data is already in there. Okay, what we need to do is we need to be able to access it using similarity searches, semantic searches, like thematic searches. To do that, we need a vector type. And I'm going to explain why coming up right here. So we're using the film table right here. And then what we're going to do, we're going to alter the table, add column, and this is the name of it. You can call it whatever you want, vector embedding, and it's a vector type. Okay? Now, this 1536, that's the number of dimensions. So if I wanted to just plot this thing on an XY chart, that would be a 2 dimensions. Okay? In fact, the number of dimensions, they're like coordinates, how I'm going to plot this thing. Okay? But we're not going to use just X, Y, or even X, Y, and Z. We're going to keep going to over 1,500 dimensions. So if you think it's like floating around, I don't even know what that is. I just know I'm floating in space, and you call this vector space. Okay, is what they actually call that. Now we added the column, and so you can see it down here when I did a describe, along with the number of dimensions, right there. And it's ready to go. So that's the first bit of secret sauce that you got to have to do this kind of stuff. Otherwise, you got to do all sorts of stuff. So so embedding. So I have till 2:15, right? All right, I got 17 minutes. Go. All right, so yeah, this is, I actually want, if you understand this whole embedding thing, all the AI stuff that you hear about or read about, for some reason, it's so much easier to digest. You just get it. Because this is always some secret mathing that people try to explain to you, and you're like, yeah, I get it, but then you really don't. And that's really frustrating for people. So, okay, so imagine, I'm going to try and explain this a couple different ways. If you get this, and you let me know, then I had one of the best days of my life, because this is really hard for people to get. So imagine each film in the Shaquilla database. I got 1,000 films. Okay, each one of those, you take all the information about the film and you just condense it down to an X and a Y. So you get all that information, you do some fancy math, and it gives you a coordinate. So each film is a blue dot right here. Okay. All right, everybody, you can get that, right? You condense it down, you get an X and a Y, and you actually plot it, okay? Now, we're going to say, let's say I have a request. In fact, my request right here is I'm interested in watching a movie set in the deep African forest that centers around their life in the community temple. Well, you take that information, just like I got from information about the film, I do use the same math, and it condenses it down to 2 coordinates, and its location is the red dot right there. Okay? So far, so good, right? Okay, so now my instruction to the, well, not to the LLM, but what I want then, I want to find like the 3 closest films that are the most similar or thematically, semantically like my request. And so in this case, it would be Forward Temple, African Egg, whoever, this is crazy database, and then Forest Sons. So it would take that film information, that would be the context, right? Along with my prompt, my request, we give that to the LLM with some instructions. That's how it gets it. So, well, how does that work? Because the geniuses who do all the math for the embedding, they make that possible. In fact, get this. If I embed like the word roof, and it it lands, let's say like right here, and if I embed a picture of a roof, it's going to be around there as well. I have no idea how they do that, but that's what embedding can actually do. Okay, people say, well, how does that work? I honestly don't know. Maybe next year I could talk about that. I'll learn about it. So anyways, so this is in 2 dimensions. So if you get this in 2 dimensions, then when we're floating in vector space, this will make a whole lot more sense. Because you think about it, 2 attributes to describe a bunch of text or a picture. That's not very rich. You're not capturing just the beauty and the depth of what's in all that data. But if you have over 1,500 dimensions, you can capture a lot of nuances. And so it's just not an X, Y, Z. It's like, boom, you're just floating in this vector space. Okay? And it's the same kind of thing, right? Think of it like this. If you had like that Shaquilla data and the film table, there's 1,000 different films in there. Let's say you had 1,000 little blue marbles in your hand right here, okay? And you're going to vectorize those, you're going to embed them, and then you're just going to go like, boom, and they're all going to go right to the coordinates. And remember, multidimensional coordinates, it's just there, okay? And those are fixed. I like to say floating, but then you think they're moving. They're not moving because they got a coordinate. That's where the embedding algorithm determine where they're going to stick. Okay, and it's all over the place. Now I have my request, like about a certain film. Okay, and that's going to end up being a red marble, and I'm just going to throw that up, and it's going to go like boom, and it's going to stick right here. And then give me the top 3 closest films. Well, there's 1, 2, and there's 3. That's the context. So it's just different, multiple dimensions. Okay. If you get that, when people talk about embedding and vectors and all, they have all these numbers. Just remember the marbles in the sky and the 2-dimensional picture, and you'll be okay. All right. And so this process, that should start moving. There we go. So remember what we've done, we added that vector type, that column with the vector type, but there's no data in there. So we had to go back, and we're actually taking some information on each of the films. We're doing that embedding process, generating that vector, those coordinates, and then we're going to update every single row, right, with its vector. And that's what's going on right there. It actually doesn't take that long. It's super fast. Okay. So what are we actually embedding? What's the text? Well, here's the code right here. It's almost like a key value thing. Film title, there's the film title. Description, the description. And so we just have basically a big long string. We give that to the embedding algorithm or the program, the model, and it cranks out the vector, which is the coordinates which we were just talking about. Okay? So it is a design decision how you want to do this. It's up to you. It's up to whoever creates the app, and hopefully they do a good job. If you screw this up, your vector in space is not going to really mean a whole lot. It'll be you'll get a point, you'll get a blue marble, but it's not going to help you much. Okay. So the embedding process. This is what we just watched. This is for each film, Okay, we're going to generate the text. That's what we just saw in the previous slide. Okay. Hey, we lost her. She took off. Oh man, see, okay. I feel bad, but not that bad. So now we're going to create the embedding. Well, we need the text, and OpenAI is going to do this. So we need the OpenAI key. We're going to actually get the embedding, which is that vector right there, and then we're going to update the film. Right, the film table for our film. That's our vector. We're going to stick it right in the column right there. And so with that, we're like ready to do the really cool stuff, and it actually just works. So this is super cool. If you can't read this, don't worry about it because I'm going to read it for you. It says, what other movies have a therapist that works with the police in them? Now, nobody writes like that, and that's the beauty of large language models. You can write like an idiot, and it should pretty much understand you because it's got a lot of idiot information that it learned on, right? That's a whole nother discussion. But look at this. It says, oh, you're looking for movies that feature a therapist or a psychologist working with the police. You might find this film interesting because it follows a forensic psychologist. How did it get forensic psychologist? Because it knows a therapist that works with the police is a forensic psychologist. That's the thematic, a semantic search. That's what all this embedding stuff allows us to actually do. I still think that's like, wow, that's so cool. Especially if you try to write code that syntactically kind of does all the regular expressions and figure this stuff out. Okay, all right, so this another way of looking at this. So I got a request. I'm going to go to the MySQL Enterprise Edition with my request with all the embedding stuff we just talked about, similarity search. We're going to get back some context, let's say 3 rows from the film table. And then we're going to build, I call this a super prompt. I don't know what else to call it because it's pretty cool. It's super, and it can get really big too if you have a lot of stuff. So the super prompt is going to contain my request, my context. Hey, it would be nice to have some chat history too, wouldn't it? Because then it really gets some context. And then we're going to have instructions like answer the request based on my context, no outside information, please, for the love of God kind of thing. And then give it to the LLM and boom, you get your response. Okay, so let's see how that actually taking place here. Okay, so there's a lot of stuff here. This is, by the way, this was all created with AI. Like I didn't actually write any of this hand code right here. Okay, and I might have had to change some stuff, but I didn't. I put it in a closet. This is what I want, and boom, it just cranked it out for me. Okay, you're going to see some of that work in a few minutes right here. So up at the top there, we need to embed the request or the query. So this is what I want. This is going to be the red dot. So it's generating the red dot right there at the top. It's going to take my query or my request with the API key. Boom, I'm going to get my vector back. We're going to connect to our MySQL database right there. Enterprise Edition on-prem, right? And then we're going to do our vector search. We're going to, we need a connection to the database. There's my embedding right there. It's going to give me back my 3 top films or however many we're asking for. In the app, we actually ask for 5, but it's easier, just to say 3. And then we're going to create our enhanced prompt here. It's not quite a super prompt yet, but it does have a bunch of the components. And you can see there's my context, there's my query, and it's going to add to it the instructions. All right, so that's the enhanced prompt. Now we got to make it super. I know. If I was to rewrite this, I would use the words that I'm using right now. So, but what the goal here is this right here. This is what we're going to send to OpenAI right here to get the natural language response right here. So this is actually going to contain the enhanced prompt, which we just did, and the chat history. So that's what this code is doing right here. So we're going to get all 4 components, right? The request, the context, the chat history, and my instructions. So that prompt, which started as just, hey, tell me something, it came from like 1 line. It can be a lot of text. And that's if it's too long, get too much stuff, the LLM can kind of get confused. Yeah. I'm not going to talk about that, but there are a bunch of other parameters you can actually, do that. And some of it's dependent upon the LLM, but some of that, that's pretty standard right there. Okay, you're burning my time, man. All right. Oh, and then there's the there's a URL. All right, for that we're going to send the request to. We're using curl for this. We execute it. Boom, we get our response. So part of, there's other stuff in there, but part of it is actually the textual response that we get from OpenAI. Okay. Oh yeah, by the way, there's a model too. That's still in the news right now. It's a cool little model. It's fast and it's relatively inexpensive. Okay, how are we doing? Got 5 minutes. We got to roll here. Okay. This is the quickest half hour of my life, man. Gosh, it is. This is crazy. I know. Can you imagine? Well, yeah, I would be going quicker. Okay, so I get to talk about the cool things that I really like. Oh, okay. So this is the hands-on lab. Watch this. Okay, if you look at this, we're interacting with Claude. Oh, we're moving down the hands-on lab right here. We're updating some code files, right? Oh, there's the code being generated, and then we test it. And then we just go through the whole thing. We give it a prompt. Claude gives us the code. We update the code files, and then we test it. And we just go in this loop, boom, boom, boom. And that's how you work through the lab. And then you'll know every once in a while we test it. Oh, we get some answers back. Okay, that's all I want to show you there. So you know how long it took me to do that? I had to do the whole thing and record the whole screen. Okay, people always ask me about this. So which model, which LLM do I want to use? I use OpenAI when I want to do quick demos and stuff like that, because every AI code assistant just gets it. I don't know why it's always OpenAI. They're really good at, but it is. Okay, probably because there's so much stuff out there. I don't know. Works really good with coding assistants, and they have a wide variety of models and stuff like that. Claude is just super bitchin' at generating code. It's so good at that, and it just works. So I like the personally. This is Craig's personal stuff here, right? There could be a lot of disagreement here, but I actually like the persona of Claude. I don't feel like I'm getting talked down to or like giving a moral lecture or something like that. It's like a colleague. I'm collaborating. I feel really comfortable with Claude. Okay, and Anthropic's I like Anthropic. Cohere, I use Cohere for the models. I use that. I can tell I'm running out of time. I can feel it. Yeah. Cohere is fantastic because it's relatively inexpensive. We're talking move the decimal point over at least once kind of a thing. Okay. Great models. It's a Canadian company, so that's kind of cool. Kind of local, Grok is great if I'm going for like truth-seeking type scientific stuff, but from an API for doing RAG, it's like way too expensive. So I wouldn't even think about that. Llama, if you wanted to deploy this make it truly like on your desktop and that kind of thing, you want to use Llama or something like that because it's open source and it's actually pretty good, and they're still releasing good stuff. So that's your super secure option right there. Gemini, those are the Google models. I haven't tried those yet. People I have talked to about it, they love it. So I just can't speak to that. DeepSeek, I don't need a reasoning model, and I don't want to wait 45 seconds to get an answer. I want it fast. So that's what's led me to OpenAI and using Claude for this project right here. Okay, so getting near the end, huh? AI ready? You can see it is not rocket science, right? You just add the vector and then you do some coding and it just works really well. By the way, this is a really simple RAG app. I call it, like dumb RAG, because you're really just getting chunks and you're giving it to the LLM. There's like a ton of things you can do to make it so much better, okay? But that's really not the objective of this. Scalable on-prem, especially if you use something like Llama, you can just stick it on your box, you're set to go. Never forget, you got a true database, and don't minimize that. Okay, what we're talking about is an extension to all the good stuff that's already there. Okay, it's not the other way around. These people just bugs me, and it's super secure. You can disconnect the internet if you architect this thing right. I thought about, why would you want to do this? Well, if you think about the whole RAG thing, why would you even want to do that? Well, you know what? If it's taking multiple SQL statements and that's how you do your analysis, you got to deal with all the syntax and all that crap. You just want to ask questions, right? And it works really good for that. If the more I work with AIs, I treat the AIs like somebody I am collaborating with, and I say please and I say thank you. Good morning. I know it's weird. My wife's like, Craig, stop doing that. You're making me uncomfortable. Yeah, but I literally collaborate, and I get really good response that way. It works really good for me. Yeah, if your data is proprietary, period, or it's normal that you just want to reference your data, then these like RAG app that's secure is like It's the way to go, okay? And people hardly, I know people that they kind of know what they do, they kind of don't, and I tell them about this, they get super excited, but then they don't want to talk to me about it again. It's like they are freaking out about it. It's this kind of thing. It's pretty scary to people, so just remember that, I guess. Next steps, you can try it out, get on-prem. You can get, if you do the hands-on lab, it's like one wget and boom, you're good to go. There's like I mentioned, tons of other rack stuff you can actually do on the ORPUB website. I did a presentation at the Utah Oracle User Group like a month ago, and I did like 13 things that I've done to actually like crank up the quality of the rack. It makes a huge difference. This is mind-blowing. Okay, we're going to do this next month. Right upstairs for the Northern California Oracle User Group, we're actually going to do this where you get multiple AIs collaborating together to help you solve a problem. For example, okay, so I say, hey, when I go on long walks, my shoes stink, right? How do I get rid of the stink? And you can even misspell the second stink and call it sink, like I did, and it still understood what I was trying to say. And you can go through these iterations, and you actually come up with really good solutions. So it's kind of a aha scary moment if you do something like that. For all the AI coding assistant stuff I use this product called Cursor AI. Has anybody used Cursor AI? Okay, there you go. Does it rock? It rocks. And they got a super liberal trial period. Check it out. It's way better than copy and pasting into Claude or something like that. Yeah, I do that all the time. Yeah, it's super cool. That's it. Oh, the hands-on lab. If you actually want to use this, I'm really proud of the hands-on lab. So go to the viscosity table, talk to Monica. We got a QR code, and it'll go right to that page. It's like private now. It's not like public. So we'll probably make it public in June. You know why? June? Because I get ACE points then for next year. That's why. Yeah, that's why. Yay! There we go. Hey, thank you guys for listening and for being here and all that. Thanks.